So we're on sheet 9. And this is question 4. Find the critical numbers, if any, and the open intervals on which the function is increasing or decreasing. So you've heard of the word critical before. When you're looking at inequalities, if you have a thing like x plus 4 over x plus 3 and x minus 2 is greater or equal to 0, what we are doing is we could get the critical numbers, the zeros of the numerator, x plus 4 is equal to 0, and get x is equal to -4 as a critical number. We could equate the denominator, each piece to 0, x is equal to -3 as a critical number, x minus 2 equal to 0, x is equal to 2 as a critical number. And then we could take these numbers on the table and test to get the sign so that we can know where it is positive for the greater or equal to. So now, in calculus, when we are asked to find critical numbers and the open intervals where the function is increasing or decreasing, we don't just go straight to the function and equate it to 0 and get the zeros of the numerator and denominator. No. What we do is, for a, y is equal to x minus 1 squared multiplied by x minus 3. We need to differentiate this function. So for the critical numbers, we'll do it in steps. For the first one, and then the second one, it will be a direct thing. So the first step, your step 1, to obtain critical numbers, your step 1, you will differentiate y. In other words, find y prime, which is the first derivative, of course. So you're saying y prime is going to be, the way the function is, that's a product. So we can let u to be x minus 1 squared and v to be x minus 3, and then differentiate u. We drop the power using chain rule, we drop the power 2 and fix whatever is inside the power, and then we'll have 2 minus 1 multiplied by the derivative of the inside. Derivative of x minus 1 is 1. This is the same as 2x minus 1, which is just 2x minus 2. And then v prime, the derivative here is 1. Then we come here now, because you're looking for y prime, you can write it here. So y prime is going to be u prime v plus v prime u, which is equal to u prime is 2x minus 2 and v is x minus 3 plus v prime is 1 multiplied by u x minus 1 squared. So our job now is to expand this. So 2x multiplied by x, we'll get 2x squared minus 6x minus 2x plus 6 plus x squared minus 2x plus 1. So I've also expanded this one. So here we'll get 3x squared minus 10x, and then plus 7. This is the first derivative. After you obtain the first derivative, you go to step 2, where you equate, or should I say solve, y prime is equal to 0. Meaning you equate 3x squared minus 10x plus 7 to 0. This is a quadratic which you are able to factorize using the factors if they're there. So we check, we have 3 by 7 as a product, which is 21. And so two numbers, when we multiply, we get 21, and when we add, we get negative 10. We will just have the same numbers, negative 3 and negative 7. Plus 7 is 0. We'll factor out 3x, we'll have x minus 1. We'll factor out 7, we'll have x minus 1 is equal to 0. This means that x is equal to 1, or x is equal to 7 over 3. So these numbers that we have obtained in step 2 are what we call critical numbers. So the critical numbers are x is equal to 1 and x is equal to 7 over 3. These are the critical numbers. To find where the function is increasing or decreasing, we use the critical numbers the same way we use them in inequalities. So we'll pick 1 and 7 over 3 and test. So bring in the testing table where you pick a number in between them. So as we can see, 2 is in between them, 3 is bigger than 7 over 3, and 0 is less than 1. What do we use here? We use the first derivative and not the original function. So we have factorized the first derivative. From here, we can see it's the same as having x minus 1 and 3x minus 7 is equal to 0. So I'm going to use these pieces in testing. So we'll have x minus 1 and 3x minus 7, and then y prime. We were interested in the sign of y prime. So when x is 0, we'll get negative. When x is 0 in the second one, we still get negative. The product of the two is positive. When x is 2, we'll have positive for the first one and negative for the second one, and negative as y prime. When x is 3, we'll have positive here, and positive for y prime. Now, where y prime is positive, so this is now step 3 in trying to obtain the increasing and decreasing intervals. So where y prime, where the first derivative is positive, that is your increasing interval. So the function y is increasing where from negative infinity all the way up to 1 union 7 over 3 all the way up positive infinity. And where it is negative, the function is decreasing. Decreasing interval from 1 all the way up to 7 over 3. Now the question emphasized that there must be open intervals, because for this type, whether numerator or denominator, we never have greater or equal. We always have greater or less. Because if you include any critical number, the derivative at any critical number will be 0. And 0 does not tell us whether the function is increasing or not, because it has no sign. And this is how you use the first derivative to determine 1, the critical numbers, 2, the increasing or decreasing intervals. This can also help you sketch, because if your interval is increasing and then start decreasing, then you know you have a relative maxima. And if it was decreasing, then it starts increasing, you have a relative minima. Do we have questions from A? Do we have questions arising from A?
Just kindly repeat on what you said about the determination of where it is increasing and decreasing.
So your definition depends on the signs. If it is positive, then it is increasing. Whenever the first derivative is positive, the function is increasing. When it is negative, the function will be decreasing.
So basically, you just do the test for the first one, but the one that determines is the y prime.
Now, even the test we are using the y prime.
Sorry?
Even the testing we are using the y prime.
Oh, okay.
The testing, these numbers we have used are for y prime. Because y prime is here. It has been factorized, is it? This was y prime, which equated to 0. So before 0 comes in, we have the y prime on the left as a factorized thing.
Oh, it's clear, sir. Thank you.
All right. Okay, so we have so many subscripts here. I'll pick f. F of x is equal to x squared over x squared minus 9. Now, the solution here will be 1, we get the first derivative. In this case, since our function is a fraction, we use quotient rule. So we let u be the numerator and v be the denominator. And then differentiate u, we'll get 2x. Differentiate v, we'll get 2x. And then rearrange it as u prime v minus v prime u over v squared. Now u prime is 2x. V is x squared minus 9 minus v prime is 2x. U is x squared. Everything over x squared minus 9, which is our v squared. So we can simplify the numerator. We'll have 2x to the power 3 minus 18x minus 2x to the power 3. Everything over x squared minus 9 squared. And then we get back to f prime. So here we can see that this guy and that one can cancel. So this can be simplified as negative 18x over x squared minus 9, everything squared. Now what we want to do here, we want to get the critical numbers. So this is f prime, the first derivative. So we know that the critical numbers are not necessarily obtained by equating this thing to 0, because we also go for the denominator. So we get the zeros of the numerator, giving us x is equal to 0. We get the zeros of the denominator. So you can see if we square root both sides, we'll have x squared minus 9 is equal to 0. This is a difference of two squares. Is equal to 0. So we get x is equal to 3, or x is equal to -3. What I've done is the same as taking 9 the other side, and then you square root, so that you get x is equal to plus or minus 3. It's the same thing. So now we have the critical numbers. The critical numbers are x is equal to a -3, x is equal to 0, and x is equal to +3. And then we want to determine whether the function is increasing or decreasing. So if you look at the denominator for the f prime, it will always be positive because of the square that is outside. So in our testing table, we'll ignore the denominator because it affects nothing. We'll concentrate in the numerator, whose signs can alternate depending on the sign of x. So we'll have our table, -3, 0, +3. 1 is in between, -1 is in between, -4 is less than, and 4 is greater than 3. And then we'll just use -18x. When x is negative, this guy is going to be positive. When x is negative, we'll have a positive. When x is positive, we'll have negative and negative. So the function is increasing where it is positive, where the first derivative is positive. So from -infinity all the way up to -3, union -3 all the way up to 0. And it is decreasing from 0 all the way up to 3, union 3 all the way up to +infinity. So the temptation that you can have here is to think that since it is positive, then it is decreasing from -infinity all the way up to 0. This won't be correct, because you would have included -3, and yet nothing happens at -3. The function is not increasing or decreasing, because that's a critical number. Nothing happens at a critical number. You must keep that in mind. Okay, so unless there's a question, we can move on. So if f of x, so for E, we have f of x is equal to 5 minus the modulus of x minus 5. So what happens here? This function in this state, you can't differentiate it. Hello.
Can you bring back the previous board? Thank you.
Okay. So for the modulus, Something is running on my screen. A minute. It's not even responding. Okay, something was running on my screen. Okay, so for the modulus, how do we define if you are given the modulus of x? We say this is positive x if x is greater or equal to 0. And this is negative x if x is less than 0. Tutorial sheet 9. Question what? Question 4E. 1120. So for the modulus, that's how you define a modulus if you are given the modulus of x. So what would we do if you are given such a function as e? We would say this is 5 minus 2 pieces x minus 5, provided x is greater or equal to 5. Because I'm saying x minus 5 is greater or equal to 0. So you take this other side, or negative x minus 5, provided x is less than 5. So the very f of x is 5 minus x minus 5 on the same conditions, and negative x plus 5 on the same condition. So that f of x as a full function becomes 5 minus x minus 5 if x is greater or equal to 5. It becomes 5 minus negative x plus 5 if x is less than 5. But this is the same as 5 minus x plus 5, which is 10 minus x for x greater or equal to 5. And it is 5 minus 5, that is 0. So we get x if x is less than 5. You've seen what we are doing to all the functions. We got the derivatives. So let's get the f prime for this function. So the f prime is also defined in 2 pieces. So we have negative 1 for x greater or equal to 5. And we have positive 1 for x less than 5. What's confusing? Let's get your voice so that you help us know where you are confused.
Sir, I'm confused where you've redefining the function.
So the redefining emerges from the definition of the modulus. So once I see the modulus function, the absolute value anywhere in any function, I have the right to redefine. Or maybe that would be too confusing. So let's leave it here and see another definition so that you see this is 5 minus the modulus of x minus 5. Now this can be written as 5 minus the square root of x minus 5 squared. It's another definition of the modulus. The modulus of x is the same as root x squared. But this is 5 minus minus x minus 5 squared to the power half. So let's differentiate f prime. Let's differentiate f. We'll get negative half. And then x minus 5 squared to the power negative half multiplied by 2 x minus 5 multiplied by 1. So that this becomes this 2 and this 2 would cancel. And so we'll have negative x minus 5 over the square root of x minus 5 squared. This means that we'll have negative x minus 5. In fact, this should be in brackets over the modulus of over the positive modulus x minus 5. So I've used another definition of it. So this is another way of getting the first derivative. And then we've been equating it to 0, so you can equate to 0 and get the critical numbers. So let's see. We get negative x minus 5 is equal to 0. That will happen at negative x plus 5 is equal to 0. So x is equal to 5. The same thing happens for the denominator. You know it is 0 at 5. So the critical number we have here is x is equal to 5. Now, if x is equal to 5, is a critical number, where is the function increasing or decreasing? So let's see if there is any. We'll have before 5, you can pick 6. You can pick 6 after 5 and 0 before 5. When you substitute 0 here, we'll get positive 5 over positive 5. That will be positive. You substitute 6, we'll get 6 minus 5, that is 1. The negative is outside, so this will be negative. So we are saying f of x is 1 increasing from negative infinite up to 5 to decreasing from 5 from 5 up to positive infinity. So when we are using the other definition, you could see that we already had this restriction here. And so going via the derivative, we could not say much things because the derivatives are coming out as constants. So we had a restriction here, but using an alternative definition, we could then obtain this as a response to this question. So I'm going to advise that this lecture, this tutorial should go as far as 20 hours. This is just 1835. And we are using Zoom platform, so we have to log out and log back immediately. We can have a break maybe in the second session. Crossing to the third session. For now, let's get back and quickly log back.